Hello, and welcome to another riveting video about trigonometry and mathematics. All right, so what we're going to be looking at here is just like how do you answer questions like, say, what is the sine of 2 pi over 3? Okay, without having a calculator. And so, what we're going to need to answer questions like this is a couple of things. First, we're going to need this little table of exact values. And so, I talked about in a previous video how to fill these in, but I will go through and fill this in rather quickly with you. So you could use the reference triangles to get this. And we talked about how to derive that, or we can do the trick where I would set up 1, 2, and 3, square root them all, and they're being divided by 2. Going back the other way would be 3, 2, and 1, and then divide every one by 2. And then we know that tangent is sine divided by cosine. So this bottom row, I'm just dividing sine and cosine to get my final row. Um, Anteaters slurp tiny creatures is relevant to tell us like when sine and cosine are positive in varying quadrants. And then of course, I always like to have my sine graph and my cosine graph here for reference, and we'll talk about that in just a second. All right, so when you're answering a question like, okay, what is the sine of 2 pi over 3? You have two things that you need to get. You need to decide the sign, meaning like oops, not psi, sine, meaning like, is it going to be positive or negative? And then the other thing we have to decide is the value. Okay. Um, so without further ado, let's just get started. All right. So 2 pi over 3. The first thing I need to figure out is the sign, and I'm going to do that by looking at my quadrants. Okay. So if I think about this, here is 0 and here is pi. Because I'm thinking in terms of increments of pi over 3, I'm not going to label this pi. What I'm going to label it is 3 pi over 3. That way, 2 pi over 3 makes a lot of sense to me. That 2 pi over 3 would be in quadrant 2, okay? Because it's one like little counting before 1, okay, or 3 pi over 3. All right, so because it's in quadrant 2 and we're dealing with sine, the sign is going to be positive. Now I need to get the value. All right, so we know the sine of pi over 3 is rad 3 over 2. Okay, now guys, the sine of 2 pi over 3 is going to be the same. And let's talk about why. If you look at this graph of the sine curve, okay, and instead of counting in increments of pi over 2, we think about increments of pi over 3. Um, 2 pi over 3 is going to be right here, 2 pi over 3. Notice how pi over 3 would end up being over here. Now, this isn't drawn to scale, but do you see how they have the same value? And it's based on the symmetry here of the graph of the sine curve. So since the sine of pi over 3 is 3 pi over 2, the sine of 2 pi over 3 would also be a positive um, rad 3 over 2. And so that's my answer. Now, positive rad 3 over 2, done. If I asked you, hey, what is the sine of 4 pi over 3? What I'm doing is I'm counting by those increments of pi over 3, but now I'm going past pi. This is 3 pi over 3. So if you envision it, 4 pi over 3 would be here. It's going to be a negative value, but the distance is going to be the same. So it'll be negative rad 3 over 2. Typically, how people answer these questions is they don't look at like the period or the cycleness of this graph. They tend to just focus on this table and then also on like what quadrant you're in. So let me do another one. So for example, what if I said, what is the sine of, or let's do cosine. What about cosine of 11 pi over 6. Can we get the value of that guy? So again, we need two things. We need to figure out what quadrant it's in, okay? So if I label this 0 and pi, because this denominator is telling me, hey, can you count in increments of 6? I'm going to change this to 6 pi over 6. It's a smart version of pi, okay? Meaning over here, this would be 12 pi over 6. So where does 11 pi over 6 lie in this grand scheme of things? He would end in quadrant 4. Okay, so anteaters slurp tiny creatures. Oh, cosine is positive, so the sign, SIGN, of this will be positive. Now, what I'm looking at is my reference angle, and I need to look at pi over 6. So I will go to pi over 6, look at the cosine of pi over 6, and that's rad 3 over 2, and that is my answer. So again, you do two things. You get the sign, whether it's positive or negative, and then you get the value. The value will come from this table, and you're pretty much looking just at what increments you're counting by. Are you counting by pi over 6s, pi over 4s, or pi over 3s? And again, I will explain why this works just looking at this cosine graph. So if I change the scale, and instead of counting by increments of 2, I'm going to count by increments of over 6. So this would be 3 pi over 6. This would be 6 pi over 6. This would be 9 pi over 6. And then at 2 pi, that would be 12 pi over 6. So if I am looking at, okay, where is 11 pi over 6 on my axis, it would be here. Okay, and so see again the cyclic nature. It is like one increment to the left of 12 pi over 6, which means it's going to be equal to that one increment to the right of 0. And so that's why I can use the reference angle of pi over 6.